A very good evening to all distinguished panelists and participants. Bharti Vidyapeeth Institute of Computer Applications and Management BVI CAM in association with Computer Science chapter of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, IEEE Communication Society and IEEE System, Man and Cybernetics, Inter-Society Relations IRS Standing Committee of IEEE Delhi Section, Industry Relations and Site Standing Committee of IEEE Delhi Section, with the associations of Computer Society of India, SAFA Society, ISTE Delhi Section, and IETE Delhi Center welcomes you all to this webinar on 6G for a hyper-connected future. In the words of Nermin Mohammed, head of telecommunication solutions at Wind River, the 6G revolution will focus on how to connect and control the billions of machines, macro to micro to nano, in our digital future. The 6G standard will truly be a next generation communication standard. This quote actually highlights the potential of the game-changing 6G technology in the present industrial enterprise when we still are trying to adjust ourselves and digest the advantages of the 5G technology. This webinar today is aimed at providing a high-level overview of 6G for a hyper-connected future to all our participants. As fifth generation 5G global rollout is underway, the focus of wireless research is increasingly shifting towards 6G. We expect that 6G will provide the ultimate experience for all through hyperconnectivity involving humans and everything. In this session, the speaker will provide a comprehensive overview of various aspects related to 6G, including technical and societal trends, drivers, use cases, candidate technologies, and the research areas. I will start this session, but will first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us our galaxy of experts. I would first welcome Professor M.N. Hoda, Director, Bharti Vidyapeeth Institute of Computer Applications and Management. A very warm welcome to the webinar, sir. I would request you now to start the webinar with your welcome address.
Good evening to all my friends. At the outset, let me first welcome Mr. Shubhankar Pal, the valued speaker for today's program. So most welcome, Mr. Shubhankar, for this program. My dear friends, the topic of today's webinar, which is 47th webinar of this evening, weekly webinar series in collaboration with IEEE Delhi section and all other premier professional societies. So for this webinar, the topic is 6G for hyper-connected network. As Dr. Ritika has already given you the background note, and Mr. Shubhankar is here to enlighten us that how and in which way the 6th generation network is going to facilitate the not only the interconnected network, not only the fully connected network, rather an hyper-connected network, and probably without that the life will become meaningless in coming days. If you see the kind of the changes which has happened in since last March or rather last January 2020, we have now by now at least we have understood that had this network connectivity, had this interconnectivity, had this complete internetworking would not have been possible, then imagine what would happen in the world. And the kind of the innovations which are happening is going to make us completely dependent on internetworking, and that's how today's topic has been kept, that 6G for hyper-connected network. My dear friends, this webinar series was started in the background of the COVID-19 in May 2020 for a simple purpose, that can we ensure that learning must continue despite disruptions. And since May 2020, this is our 47th weekly evening webinar series. Few weeks regular and few weeks alternate weeks we are organizing. And the purpose is to ensure how all of us can remain connected, how all of us can continue learning despite disruptions. And that's how it is said that the purpose and the objective of this webinar is to ensure that those who are feeling disconnected, those who are feeling isolated, those who are believing in disruptions should disbelieve it and should ensure that learning must continue. And that's how a great poet has said that यही है जुनून मेरा, यही है शौक मेरा, यही है जुनून मेरा, यही है शौक मेरा, चिराग वहां जला दें जहां है अंधेरा. So thank you so much. I also take the opportunity to acknowledge the presence of Professor P.S. Grover, who has been a professor when I was a student. So thank you so much, Grover sir, for joining this, who always have a zeal to learn new things, and that's how he is here. I have my friends, Mr. Ajay Goel, who is always a source of strength to me for all these programs, for connecting to me to different speakers from variety of industries on a variety of the topics which are of importance to all of us, to all professionals, to all technocrats. Thank you so much, Mr. Ajay. I have Professor Bhatia from Bangalore joining us. And believe me, since May 2020, almost all programs he is attending is a great source of motivation. I also take the opportunity to thank to all my friends from different professional societies like IEEE, IET, CSI, IST, IITP, and all other professional societies who have given their approval to collaborate with this program right from its inception. So thank you so much. My dear friends, Dr. Ritika has already sensitized you about the next webinar, which is scheduled on 18th of September. If you have not registered by now, please register for that program and derive maximum benefit. See to it that if you be attentive, if you be active, if you be rather proactive in the webinar, then only you will learn, and the learning is the basic objective for this. And the process of getting certification will also be explained to you and will be placed in the chat window by Dr. Ritika. If you miss to get the link, please do not leave the meeting room, because the link will be given right in the meeting room. If you leave the meeting room and then you start contacting us on maybe on email, maybe on WhatsApp, maybe on telephone call, sorry, we won't be in a position to help you out to get the certificate. So get your queries related to certificates resolved through the chat window right in the meeting room. So thank you so much. Wish you all the best. And again, we are hearing news from different parts of the world about the third wave. So be careful, stay safe and stay healthy. With this note that नाजुक है वक्त, नाजुक है वक्त, संभल संभल के रहिए, नाजुक है वक्त, संभल संभल के रहिए, जब तक न हो बहुत जरूरी, घर के बाहर ना निकलिए. Wish you all the best. Stay safe, stay healthy, stay vibrant, and keep learning. Thank you so much. Over to you, Dr. Ritika.
Thank you, sir. I would now welcome amongst us our expert speaker, Mr. Shubhankar Pal. Mr. Shubhankar Pal is Assistant Vice President and Global Research and Innovation Leader for Future of Network Program. His responsibilities include technology product incubation, consulting, solution creation, and service offering definition in the area of machine learning and artificial intelligence for IoT and telecommunication markets. Prior to joining Capgemini Engineering, he worked at Nokia Networks and CDOT. Shubhankar also has extensive experience in speaking at international conferences and presenting technical papers in various forums. He has published white papers in IEEE Forum and other international events. I welcome you today to this session, sir, and I would now request you to kindly enlighten the House.
Thank you, Dr. Ritika, and thanks to Professor Emin Huda. It's a great honor and pleasure to be here and inviting me for presenting in this esteemed session. It's a great platform to present my views on one of the very interesting and futuristic technology, which is 6G. And the topic for today is 6G for hyper-connected future. I hope my screen is visible to all of you, and I'm also audible.
Yes, sir. Perfectly visible.
Thank you. Okay. So Um, so let me take you to say 10 years in the future. Let me fast forward the time. Wish I could do it in reality also. But let me do it at least in the session. Let's all think that we are in 2030, 10 years, around 10 years from now. So how the communication will be, how what will be our life there. So one thing that is for sure, will not be communicating in the way we are doing today. What will happen in 2030 is we'll have a completely different experience when say I am calling you or my friends and family. Today what happens is when I want to connect to someone, it is only through either audio or the visual. I can see the other person the way you are seeing me and hearing me. This that is the only possibility up to 5G. But uh, in 2030, I think the life will be much different. It will be much more realistic. It will be like much more a real life experience where the 3D holograph communication will help me to have the holographic teleportation. It is not the teleportation that we know from Star Trek. It is not an atomic teleportation, but it's an holographic teleportation where the complete 3D visual of that person will be in front of me as if he's standing or sitting in front of me and he's talking. What you see in this picture. This is an experiment that Vodafone had done some time back, where this player was holographically present in the stage with this little girl. Though it was done using 5G, but I think that the experience and the communication and the diversity that you can have in 6G will be much higher, and it will be not only for experiments, it will be like real life at the time. So that is the power of um, the communication. That is the kind of experience and enrichment in the way we communicate with each other. You will see in 6G. Let's talk about another use case, which is multisensory XR. So XR stands for extended reality. So with 4G and 5G, we know we have the VR or the AR, where I can wear this nice yeah, gadget. This is the headset that I wear, and as I wear this headset, I can have a full immersive experience. That means I can see and feel things as if I am inside that environment. For example, if there's a roller coaster ride, you might have, if you have seen it in some of the shopping malls or some of the gaming zones. If you wear this and get into this roller coaster, you will feel as if you are actually inside the roller coaster. It's not a virtual reality. The same happens with AR also. Your visuals are extended with more information as you see things about, say, how the health of a machine is, or maybe if you're seeing a plant, what is the variety of that species is, and so on. So this is possible in 4G, and it will also get enriched in 5G. But what you will see in 10 years from now is you not only have the audio and visual, like the sound and the sight. It will be all the six senses that you will see. That means digitally I can touch, which I think will be possible to some extent 5G, and will be much more fuller uh, touch, that is called haptic in 6G. There will be smell, there will be taste, there will be sound. So there is a nice blog from Ericsson, if you see in the internet, that talks about this multisensory XR. It means that the XR will be as if it's a real world. For example, my mother is cooking a nice dish. I can not only see it, but I can also maybe smell it, and who knows, I can even taste it by that time. So it is not a science fiction anymore. It is becoming reality. Multiple experiments are happening around this. we all have heard about Hyperloops. There are experiment tests that are happening. So Hyperloop is a super speed ground level transport where people can travel in this hovering pod that you see in front of you in a vacuum tube. And the speed in which they will travel is 1000 kilometers per hour. So you know there is 4G, there is 5G, and there is a cellular network, and handovers happen. Can the 4G or 5G handovers be so efficient, that a person traveling at a speed of 1000 kilometers per hour, he can still be connected seamlessly with his friends and family outside? Uh, let's think about it. Okay. The next one is another very interesting thing is around the urban air mobility. So we know this helicopters or we know aircrafts that hover around. So either we get into them and go to different places, or we can use the ground transportation today. For example, if I have to go to office today, I of course will not use a helicopter. I will not use a aircraft, and it is not affordable also. I will use my car. I will use a Uber maybe, but then there's a chance that if it is it is during the office hours, there can be a massive traffic jam and I'm caught in the jam. Is it possible to have this kind of vehicle that you see in front of you right now? Can I use these vehicles to, which are called urban air mobility vehicles, or more popularly known as air taxis? That means they are 500 to 5,000 feet above the ground and get the that uncrowded space where they can move fast. Maybe they're still moving inside the city, or maybe an intercity transport for which they're using this vehicle, but it is not for a very long distance. So the idea here is that they are above the ground and they're into these air taxis, and they're traveling much faster in a congestion-free zone. And they're electric. They are not as noisy as helicopters. They need a very small landing place to land. Maybe even in top of this building it can land. So that is the beauty of this urban air mobility. But if I'm inside this vehicle, like 4 or 5 of us who are traveling together and want to connect to my office, is it still possible? Will the terrestrial antennas still be able to connect me, which are actually pointed toward the ground? Can it still help me to connect? Let's think about this. Another very interesting example is swarms. So what you see here is a swarm of drones. So what they are doing, they are either hovering around and sprinkling insecticides, or they're sprinkling fertilizers, but they're doing together in a fully connected mode. That means this drone is talking to this drone, and maybe there is a drone above them. So maybe a drone above them is taking continuous pictures and finding out what are the infected places and where there is more insecticide has to be sprinkled. So it will tell this drone that go to that place or sprinkle more. Or this drone will tell to this drone, okay, I'm already here sprinkling. You can go to some other place and do the job. Or have sprinkled the insecticide. You can now sprinkle the fertilizers. Same can happen with robots also. So the swarm of robot that work on, say, in a warehouse. So maybe that there is a autonomous guided vehicle that comes in with some goods, some packages. Then there is a robot which picks up and climbs the shelves and puts it on the top of the rack, all working together. So whenever the vehicle comes in, it tells this robot that, okay, I've come in, now pick it up. Maybe it goes up to some point and gives to another robot which can climb. The climbing robot climbs and puts it the shelf and says, okay, the work is done. So and it is also used by the military as well. For example, the drones can all work together to maybe attack the enemy. So what happens is that there is a a huge number of smaller objects we have to connect and work together in tandem to achieve a single goal. That is the swarms about. It can be swarms for the drone that you see here, swarms for the robots, or swarms for robots and other vehicles which are autonomous. So these autonomous swarms is how things will happen in a machine-to-machine communication in the next generation. Okay, so what does all this means? It means that we are talking about a altogether different kind of human machine communication. So what I have done, whatever we have seen there, I've tried to map it in this 4x4 quadrant, like how the human to human communication will be, how the human to machine communication will be, how the machine to machine communication will be, and maybe what is the machine to human communication will be. Now let's see each of them, because this is the basis for my the next section of this presentation, which talks about the technologies and other related areas. So we already saw holographic telepresence, which is one of the bigger use case. There is another use case which is extremely remote area connection. Maybe there is a remote village or places where it is not possible to have terrestrial antenna, maybe somewhere in a very hilly and remote area, where if I put a terrestrial antenna and there are only few people there, it costs a lot for me to maintain that network there, but the revenue that I get is very less. Or even it is not possible to connect this antenna to the backhaul system. So in that case, what happens is it is better not to use a terrestrial antenna. Rather, maybe I should use a low orbit satellite, which is called LEO. I'll talk about that in a moment. But you see what Elon Musk is doing with Starlinks and the constellation they are creating by launching rockets every few months. And that is exactly will be the next generation of networking, where it is not only the terrestrial network that we know today, it is about connecting each and everyone with the highest possible experience and the bandwidth that he needs. Okay, and then we spoke about an extremely high mobility. The extreme high mobility is what we saw in Hyperloops, but it can be extended to other use cases as well. For example, maybe who knows, it will be so cheap in the next 10 years that going to space will be affordable by common man or woman. So that means that if I am a space traveler, I'm traveling in space and I want to connect to my family on the land in my home, is it possible? I think it will be with this new kind of network that we're talking about. We'll see how. The next set of use cases will be around human to machine communication. Multisensory XR we already discussed. We saw in that example. That means it is about all the 6 senses that we spoke. Brain computer interface. That means I don't need the remote control, or I don't need the joysticks to or some other remote communication means to control my system. It is I will wear a gadget on my head and it will transmit my brain waves directly to the computer for the computer to take my command and do the necessary work. It will be an extremely important thing when working with hundreds of machines in a factory. There is another important thing that is coming out also related to brain computer interface, is called personalized body area network. So tomorrow it may so happen that I'm wearing jackets with lot of sensors and lot of connection points, which gives me a different kind of experience. For example, I may have 2 different arms which are connected to my body and they work along with my real arms. Or maybe I'm wearing a kind of jacket that is giving me extra power to do something which humanly is not possible. So these all are happening and will happen in a altogether different level in 6G, which is around the personalized body area network. And there are also discussions about implanting some of these gadgets into the body so that it can permanently be used inside the body. Then there is this um, altogether new area of machine-to-machine communication, which started with 5G, but it will go to a completely different level in 6G. One is the massive twinning. So digital twin, I think around 4 to 5 months back in this forum only, I had given a presentation on what digital twin is. Digital twin is changing 5G. That means it is creating a digital replica of the physical thing so that it can be managed well in an industry context. But that can only be for a device or a set of devices, or maximum for a factory. But we are talking about twinning at the level of the country. We are talking about twinning at the level of Earth. So there is a use case on Earth monitoring. The entire Earth has been twinned digitally and can be monitored what is happening where to the lowest granularity that is possible. We discussed about autonomous swarms already, the autonomous drones and autonomous vehicles. And then there are zero energy IoT. That means today every IoT device is battery operated. What if there's a device somewhere placed unattended for several years, who will go and replace his battery? So the next generation of technology will see the possibility of zero energy IoT devices. That means the energy is transmitted wirelessly to these devices, a small amount of energy for them to do their operation, and there is no battery in those devices. And then there is a machine disaster response kind of scenario where rather than human talking to the machine, it is like a machine talking to the human. That means that there is a disaster that is predicted based on certain algorithms. It can tell, okay, the disaster is going to happen. It can give an accurate prediction of the disaster and also back up the network accordingly. For example, the terrestrial network that is predicted to go down. So the entire communication may switch to a satellite network at that time. So this is will be a different kind of communication altogether. Okay, so with this, let me get into the 6G requirements and timelines, which can fill this kind of things, or which can help us to realize, if not all, some of them. Because 6G, I think, is still not defined. It is just started. It is still in research. We don't know what will get into the 6G specification and what will not. What I will be presenting in next few slides is about the kind of research we are doing in-house in our organization, and the collaboration that we are having with different universities, and what we are seeing, what our customers and our partners are doing. So before going to uh, 6G and talking about 6G, you might be wondering that even 5G is not rolled out in India. 5G has just been standardized, and there are trials going on in some places. A limited rollout is happening. Why you are even talking about 6G? Why so early? We are talking about 6G here for these three main reasons. There are new use cases that are already knocking our door that we are seeing today. Maybe 5G is not covering them, but we are seeing those use cases are there, the one that we just spoke about. And we are sure that 5G cannot cater to those use cases. For example, say a Hyperloop communication 1000 kilometers per hour. I don't think 5G can support that high-speed mobility. The second is the experiments have already started. FCC has opened up the sub terahertz to 3 terahertz frequencies. So that has helped to start research in 6G and beyond. So the experimental spectrum has been released by the Federal Committee. So that has helped us to do many research. I think only a few weeks back there was a press release from LG where they have claimed that they have done the first uh, sub or close to terahertz spectrum communication. So they could send and receive signals through a sub terahertz spectrum, and that itself is a big achievement, and I will say the onset of the 6G research that has started. The third reason of why we are talking about 6G is the research timeline. You might have seen that um, the 5G started somewhere around 2010 or 29 at I mean 2009 or 2010, and it went 10 years, and then it started rolling out starting of 2020. And same was with 4G and 3G. So the wireless technologies take around 6 years to mature. Sorry, 10 years to mature. So something of that timeline. That means 5 to 6 years it takes to get into the pilot stage, and with the initial set of specification, and those trials happens across the world, and the production rollout happens in 10 years. So if we start now, we'll be rightly placed in 2030 to unveil the 6G um, um, uh, networks. So it's about the use cases. It about the government's support to start the research, and it's also about the time we are in when we should start 6G. That is why uh, we are talking about this, because the research have already started several places in universities, the different industries, the different service providers, network equipment providers. They have started the 6G research already. So what are the requirements of 6G? So I've just picked up one comparison between 5G and 6G. Maybe I will not go through all of them, but these are the kind of requirement that we are seeing from different research. Again, this is not a specification, so don't take it as casted on stone. This may keep on changing, but few things that are important to see here. We are talking about a peak data rate of 1 terabyte per second, which is like 20 gigabyte per second, which is possible in 5G. And this is perfect for high volume communication like holographic teleportation that we had discussed. Okay, so the maximum bandwidth that we're talking about is around 100 gigahertz, and the mobility that we are talking about is 1,000 kilometer per hour, which is closer to what a hyperloop kind of mobility needs. So whatever we have discussed in our previous use cases, now you should be able to map it. Why I have put those use cases, why I was presenting these use cases, because we are talking about requirement that cannot be fulfilled in 5G anymore. Okay, so what are the timelines of 6G? So 6G, so at this point of time where we are in 2020, 2021, most of the 5G specification work is over. We are somewhere in release 17 right now, and we are seeing the 5G specifications are done, and beyond 5G specifications have started coming in. And the 6G's vision and the requirement have also started coming in from ITT. ITT has created a future group for studying the gap in 5G and defining the vision for 6G. That if you go to the ITT's website, you will see some papers and presentations around their vision of 6G already. So the requirement will be then available somewhere in 2024, 2025, and the actual trials will start somewhere between 2025, 2026. And so this is where most of the NEPs and CSPs will come into action and start trialing in the telco networks. So you'll see a lot of test beds coming in, and only in 2030 and 2031 when the actual 6G will roll out. So it's like the 10-year cycle that I was talking about. Okay, so what are the trends in 6G research? What is going on? What is happening now? So there are so many different trends that are there, but I didn't want to overwhelm with all of them to you. I am just presenting four, or I've tried to put all the majority trends into four different buckets. Maybe I might have missed some of them because every day there are new things that are coming in, but this is what at least I am tracking as part of my 6G research. Okay, so the first one we are talking about is terahertz frequency. Okay, so excuse me for the typo here. So the terahertz frequency is because we are talking about frequency that goes beyond what 5G is provided, and from sub terahertz to several terahertz will be the frequency in which the communication will happen. Though the 5G bands will still be there, 4G bands will still be there, but all those high-speed communication where more bits can be sent over the same spectrum can only happen in terahertz frequency. I'll talk about that in a moment. And it can even go beyond terahertz to visible light communication. That means um, the lights in my house or light in the shopping mall, they can also be the source of communication. So when I'm talking to my friend, I'm not using maybe a Wi-Fi, I'm using a visible light from those LED bulbs that are there in my house, or that are there in a hospital, or that are there in a shopping mall. So that is the interesting news page. And then I'm talking about the physical techniques. That means the physical radio I'm talking about. There's a full duplex communication that can happen. The full duplex communication, because now we need two different channels for uplink and downlink. But it will be one, if I can use one channel for both uplink and downlink, that will save a lot of my spectrum. So that is another research that is going on. Sensing and localization. So sensing and localization is what happens today if I'm inside a mall or inside a big building, my 4G or 5G network don't work. And don't work in the sense it cannot help me to localize or position me indoor. So you might have seen those Bluetooth beacons or Wi-Fi that helps me to, even if there is no map, that helps me to find out where I am actually. Okay, so what happens in this case is we are not able to uh, position properly. So in that case, what I do is I use my Bluetooth beacons or Wi-Fi. With 6G, it will not be the case anymore. I can directly use my 6G connection thanks to the smaller frequency, I mean the higher frequency bands and smaller wavelength. That is helping me to uh, find my location very accurately, even indoors. And then there are new architectures like 3D architecture. It means that I can use satellite to connect on land, on sea, and on uh, and also in space. Okay, and then AI native will be a big thing there. Networks are having AI in 5G, but you will see a more native AI interface, more native AI slicing. If there's a time permits, I'll talk about that. Okay, so few of them I will touch upon. Not everything I can touch upon. I think we don't have much time left. The first one is the terahertz frequency. So if you see this frequency band, the lower bands were used in 2, 3, 4G, and then 5G were using gigahertz band, and 6G experimental spectrum has been given in this range of 95 gigahertz up to 3 terahertz. So this is the spectrum in which now all the experiments of 6G is happening, and it can even go to visible light. There are some experiments happening there. That means I can use the light that I can see to use this, especially for indoors. So it gives me huge data rate, but it also brings challenges like propagation loss. If I'm using a higher frequency, then maybe I cannot transmit my signal to a very long distance. Then I need repeaters or antennas at a more close spaced area. And then there is a molecular absorption. That means air can absorb, air or molecules in the air can also absorb those signals. That is also a challenge that research is happening. But most importantly, I'm going to a higher frequency band to send a higher bandwidth, but it may need some architectural changes in the network. The second one is a completely disruptive thing that is going to happen. We are now in a cellular technology, like 4G, 5G is like this kind of honeycomb cell. I'm in this cell. If I'm traveling to another cell, and handover happens from this antenna to this antenna. What I will see in 6G, and there research and discussions happening, that there will be an ultra massive MIMO antennas that will use beams that will, and these antennas will be stateless, so that there is no cell that is required. So I connect to this, or I connect to this, I can connect back to my backend network, and it hardly matters where I am, and there is no handover or all those complex procedures happening. So, and there is lesser interface because we are using beams and not a kind of broadcast. So this cell-free networks where cells will not be there will simplify the network immensely. And then what will happen is in a mesh network will come in. There'll be repeaters. There are radio antennas which are stateless and having very less control features here. All the control features will be virtualized and will go to the centralized network. So it will be like a mesh network. So what happened earlier is, when I have to connect to someone else, I have to go to the radio network first. So it's all like a hub and spoke. So from my place, I have to connect to the radio, and the radio has to connect to the core, and then it will go back to the other person. But now it will be like a mesh network. That what I've seen in Wi-Fi. So I can connect to this guy, I can connect to this guy, and ultimately it takes to me to the core network. So it's like a mesh, which is much more easier, much more available network. And then uh, what Elon Musk and other people are doing, which is called new space. The new space is about a lot of satellites that are coming in. Then there are HAPS or high altitude platforms that are there. So all these are creating a new possibility of network which is not connected with 5G now. So the LEOs and HAPS are not connected. I think HAPS will be connected in beyond 5G, but not otherwise. So all this, we'll see that they will all be connected in 6G to make a completely different kind of network which can work in sea, in land, and in air. So that is, it is also called a 3D network. That means it can connect me in an urban scenario where maybe if the terrestrial network is congested, it can be used. I am say deep inside this, maybe somewhere in the middle of the sea or an ocean, maybe in a cruise, or maybe I'm in somewhere in the air. Everywhere I'm connected, and not only connected, I'm getting the same kind of experience, same kind of high bandwidth. That is what we'll see there. So you'll see connectivity in an urban space where the terrestrial network can be bypassed or can be complemented with the satellite systems. It in rural places where the connectivity is limited, it can be backed up with with a satellite system. In the remote places where there is no network now today, you go to somewhere in Himalayas, you will not get network today. Thanks to the satellite network, you will get it. You might have heard about what iPhone has been doing press release about. They're saying that their next generation of phones will also have facility to connect to the satellites. That is what you'll see in the future. Your phone, your handheld devices that you have, you don't need an extra gadget, and you'll be also be able to connect to the these antennas, these satellites, and maybe you are somewhere remotely in the aircraft or in a cruise. So uh, so that's all about like what are the different technology. There are many smaller other things that are happening. For example, there are materials that are um, uh, uh, reflecting materials, so that like it can reflect the signal to other users. So that is another possibility. But interest of time, I will not go through all the smaller technology. These are like big trends that are happening in 6G right now, the research areas. So what are the global initiatives that are happening? So there are several global initiatives that are happening. I cannot go through all of them today, but some of the big one is like HexaX, where Nokia and Ericsson have come together in Europe to form a consortium for 6G research. There is a 6G flagship research happening in Finland. That's, I think, one of the bigger research that is happening. NextG is a European equivalent in North America, where AT&T and some other big names are there. And then a lot of smaller and bigger work is happening in Asia. For example, in Korea and China, a lot of research have started. In India also, there is a technology body called TSI, which have started participating in the 6G research. So global initiative has started. It is already there, and it is already shaping up. In next 5 years, we'll see things becoming more real and the trials happening also. So I think I'm almost on time. So I've covered most of the things about what the trends are, what the research is happening, what the use cases are, and where things are heading in the industry. So with this, let me stop and ask you if there are any questions.
Yes, Shubhankar sir, you have wonderfully explained and very simply explained this new technology, I would say 6G. We have a few questions that I will now take up with your permission.
Sure.
Yeah. The first question we have is, how are senses like smell, touch, etc. enabled in 6G? And is it actually for real?
Yeah, that's a good question. I mean, that also keeps on bugging me, that are they real? But if you see the go to Ericsson's website and search for Internet of Senses, they have a nice blog that talks about this. Some of them are already real now. For example, haptic. And I will give you a very small example. Uh, iPhone has removed their home button, I think, I don't know, from version 8 or 9, right? So there is no home button now. So you just touch on the touch screen's home button. That's a virtual button, not a physical button. But when you touch that button on iPhone, you get a small vibration, as if you are touching the real button or a physical button. So that is haptic. That means the sense of touch. And there are other experiments that are going on. If you go to YouTube and search for haptic communication, you will see a lot of experiment that is happening, which gives you a digitally a feel of you are touching the real thing. So, for example, say I am purchasing a wallet, or I'm purchasing a small bag, and I want to also not only see and verify, I also want to understand what kind of material it is, and I want to touch that. So that is the next experience that we can give to the retail users who are purchasing online. So if he can not only see the things in 3D, if he can also touch and feel the fabric maybe of that bag, that is what will be this internet sensor. So some of things are happening, like haptic will surely go to come, but how much about smell and taste? I mean, the time will tell. As I'm saying, that these are like initial days of this research. So, but a lot of work that is happening by different industry bodies. Let's see how it goes.
But does that imply that we can tell our students that super artificial intelligence is no longer just research? It will be true in the near future. Like by the time they would be in industry and they would be doing better, they would already be working with it.
Absolutely. For example, I talked about this multisensory XR. You see those examples that are happening. So, um, for example, you think of a situation where you are using your brain waves to control the robots. How useful it will be if, say, for a differently abled person who has lost his arm or leg, he is not only like wearing this gadget, he can also moving those artificial arms and legs um, with their brain waves. And if we use this AI sensors, he can do much more about that. So this is how the things will be, and you are also seeing glimpse of this in 5G already. So I think it will be real. We don't know whether it will all land up in 2030 timeframe or it will go beyond that, maybe in 7G. But what is important is that the research has started, and there are examples and use cases that are already demonstrable in this space.
Yeah, sure. Thank you, Shubhankar. Next question we have. How will 6G interface with 4G, 5G? Because we still have 4G and 5G predominantly in a country like India. And if we go over to the less, I would say, places like smaller towns and villages, even 2G exists till today. So, how is 6G going to interface with all this? And what will be 2G in the future like?
That's a good question. So I think whenever a new technology comes in, we have seen it in 5G. When the 5G is coming in, it is not throwing away 4G. 4G is still there, and maybe in urban places it will go away after some time, but in rural places or suburban places it will still be there. So there will be mechanisms for them to interpret and interplay. And 6G is also about not only the terrestrial network, it is also about connecting the satellites, connecting the other forms of communications like HAPS, the high altitude platform, which are not there today. So maybe we'll also see some kind of interfaces of those entities with 4G as well. Because if you see what 6G is about, 6G is less about human to human communication. It is more about maybe machine to machine communication. It is more about user to machine communication of a different kind. So on all those places, 4G is not there, and 5G also will be very limited. So maybe for those use cases, it only be 6G, but all those other use cases or traditional use cases that we know that was working in 4G and 5G, it will still be there, and there'll be some backward compatibility already.
Thank you, Shubhankar. One another thing I would be very interested in asking. Whenever there is an advancement in this G, I would say there is one like a whole batch of researchers who are concerned with the health hazards, and I would also be concerned that what would be the health hazards on human beings as well as other living beings of this 6G, and maybe with 6G we have next 7G which is coming. So, what will be the health hazards as such?
Yeah, so there is no proven facts about um, if there is any health hazard that is happening because of these 4G and 5G, and that also goes for 6G. Though it is going to have higher frequency, but these higher frequencies are already there today. Satellite communications are already happening. You are using this smaller antennas in your house to get the satellite channel. So those frequencies are already there. So I think what goes for 5G is also will be true for 6G, that there will be there is no proof today that there is any hazard, that the health hazard that is going to happen. But that is something is surely one of the things of research. That means anything that comes in should not harm the human being, should not harm the planet. So that is always in there, and that will be much more stricter in 6G, given the regulatory norms will be much more tighter going forward. And that will also happen to related things like energy consumption and so on. So I think that should be taken care of whenever a new technology comes in.
Thank you, Shubhankar. I think this discussion can go on and on because there are so many things to discover this technology. I'll end up the question and answer with one last question, which I think another interested researcher has put up. What will be the underwater applications in terms of 6G research? Like, what are the underwater possibilities?
Yeah. So the underwater possibility will also come in this non-terrestrial network communication that I was talking about. So the non-terrestrial network is connecting the satellites, the HAPS, and other form of airborne communication systems with the terrestrial network. So this is helping us to go to the places where the current technology cannot come in. So there are two possibilities for underwater. One is that these satellite communications can be directly be used by the underwater submarines, maybe, or there is a possibility that they are relayed using some of the ships that are afloat and are on the surface of the water. So maybe not directly communicating to satellite. They first are relayed through the ships, and ship then goes and connect to the satellite. So as I spoke about, there will be mesh connectivity going forward. It's not that I always need a radio antenna to communicate. If I'm not in front of a radio antenna, it will not communicate. If there is any router, or even my colleague's phone can be helping me to communicate to the nearby radio antenna. That means it's like connecting with or relaying the signals with the nearby devices up to the antenna. So that can also happen with the underwater underwater submarines and other such vehicles, which can connect to the ship or any other um, uh, um, kind of floating objects in the surface of the water, and then that can connect. Now, what will be the use case that we have to see? I mean, I don't know about the use cases, but maybe a deep sea exploration, talking about the experiments we do on, say, the marine world. That can be few use cases that we will see that are coming in. But it is, I think, very early days to talk about that now.
Absolutely right, Shubhankar. I would agree with you on this point that this is one technology that holds a lot of promise in the future, and we still have a lot to explore on this. With this, I would also thank you for today's wonderful session. We have always learned from your sessions, and we look forward to it in the future also. I would now request Professor Huda sir to kindly present a certificate to Mr. Shubhankar Pal for this wonderful session today, just as a token of remembrance for this wonderful session.
So, Mr. Shubhankar, congratulations. Today's session has really been very fabulous, full of information, full of the technological trend, and probably the things which we have discussed 2-3 years down the line, we will start realizing those trends on the ground. And this certificate is only to remind you always that you have been part of this wonderful webinar with Bharatiya Vidyapit under collaboration with IEEE Delhi section. Thank you so much, Mr. Shubhankar. We'll meet again.
Thank you so much, Professor Uda.
Goodbye.
Thank you, Shubhankar sir, once again for this wonderful webinar. And with this, we come to the end of today's wonderful webinar. I would also like to extend a big thank you to all our distinguished panelists and participants who have continuously supported us through all our webinars. A big thank you to all of you who have also joined us today on this auspicious day. With this, we come to the end of another wonderful session where I suppose all of us have learned a lot about a new upcoming technology, which is again the future, and I would say the very near future, because with the one thing that we have learned with this pandemic is that we'll need to continuously evolve and develop ourselves if we want to sustain in this world. So with this, we come to the end for today's wonderful session. Feedback link has already been shared with all our participants. I once again thank all my distinguished panelists and Shubhankar, who has been a wonderful speaker for our sessions and has given us another wonderful session today. So I once again thank all my panelists. Thank you so much for being with us today in this session. Our next session for the same is on another cutting edge technology is planned on 18th of September. Feedback link for today's session has already been shared with all the participants in the chat window. And as I can see, my number of participants is continuously reducing. So I suppose all the participants, they have received the feedback link, and they are filling and submitting the feedback form and receiving their certificate. Dear participants, kindly do not leave the meeting room till the time you receive your certificate of participation in your inbox. because the meeting room now is locked. Once you leave, you will not be able to rejoin. So kindly stay here till the time you do not receive your certificate of participation. I request all participants kindly fill the feedback form on time so that your certificate can be generated on time. 80 plus certificates for the session have already been successfully generated. Others are being generated. So I request all participants, it's already 7. The feedback link is only open till 8:30 p.m. So kindly ensure that you submit your feedback on time so that your certificate can be generated easily. Please fill your feedback form carefully without any mistakes so that, because everything that you fill directly goes into your certificate. I hope you all enjoyed today's session. Thank you once again for being a part of today's session. And I hope you all rejoin us back on 18 September for our next session. There are a few queries from our participants. Last session link has already